wiring installation described is unsafe and does not meet electrical code requirements. Firstly, the 20 amp GFI breaker isn't sufficient to protect both pumps. The total load current is 10.8 amps plus 1.8 amps equals 12.6 amps, which exceeds the breaker rating. Each pump should have its own 15 amp breaker. Secondly, the number 12 wire from the breaker to the pumps is too small for the combined load of both pumps. The maximum allowable current for number 12 wire with a 90°C ambient temperature rating is 20 amps. The wire should be upgraded to number 10 or number 8 to meet the load requirements. Thirdly, the number 14 wire used inside the Intermatic box is also too small. The maximum allowable current for number 14 wire is 15 amps, which is insufficient to carry the combined load of both pumps. The internal wiring should be upgraded to number 12 or number 10 to ensure proper operation. The freeze protection relay should be on its own circuit with its own breaker. The use of a double throw breaker is not appropriate for this application. The installation should be inspected and corrected by a qualified electrician to ensure safety. The concerns are valid. The wiring installation is not safe and does not meet electrical code requirements. It is important to rectify the issues to prevent potential electrical hazards. To elaborate further, let's delve into the specific reasons why this wiring setup is not only non-compliant but also presents a significant safety risk. A crucial aspect of electrical safety is ensuring that all components are adequately sized to handle the intended load. This involves correctly assessing the current draw of each device and selecting wires and breakers that can safely carry that current without overheating or causing a fire. In this scenario, the primary issue stems from overloading the 20 amp breaker. When both the 2 horsepower main pump drawing 10.8 amps and the 3/4 horsepower booster pump drawing 1.8 amps operate simultaneously, they collectively demand 12.6 amps. While this value might seem comfortably below the 20 amp breaker rating, it's essential to consider the continuous load factor. According to the National Electrical Code, NEC, a continuous load is defined as a load that operates for 3 hours or more. In such cases, the breaker must be rated for at least 125% of the continuous load. Therefore, for a 12.6 amp continuous load, the breaker should ideally be rated for at least 15.75 amps, which is 12.6 amps multiplied by 1.25. Since a 20 amp breaker is used, it might appear that the breaker is appropriately sized. However, the problem is that both pumps should be on separate circuits with appropriately sized breakers to protect each individual motor. The use of a single 20 amp breaker for both pumps does not provide adequate protection. Overcurrent protection devices like circuit breakers are designed to trip and disconnect the circuit when the current exceeds the breaker's rating, preventing overheating and potential fire hazards. If one of the pumps experiences a fault or draws excessive current, the 20 amp breaker might not trip quickly enough because the combined current of both pumps would need to exceed 20 amps. This delay can cause the wiring to overheat, potentially leading to insulation damage, short circuits, and ultimately a fire. The recommendation to use separate 15 amp breakers for each pump addresses this issue by providing individual overcurrent protection for each motor. If either pump experiences a fault, its respective 15 amp breaker will trip, isolating the faulty pump and preventing the entire circuit from being overloaded. This approach enhances safety and minimizes the risk of electrical hazards. Moving on to the wire size, the use of number 12 wire from the breaker to the pumps is also problematic. Number 12 copper wire has a limited ampacity, which is the maximum amount of current it can safely carry. The ampacity of a wire depends on several factors, including its material, copper or aluminum, its insulation type, and the ambient temperature in which it is installed. According to NEC Table 310.15, number 12 copper wire with a typical insulation type like THHN or THWN has an ampacity of 20 amps when installed in an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. However, the ampacity of the wire must be derated or reduced if it is installed in a higher ambient temperature or if multiple current-carrying conductors are bundled together in a conduit or cable. In this case, the number 12 wire is carrying the combined current of both pumps, which is 12.6 amps. While this current is below the 20 amp ampacity of a wire, it is still advisable to upgrade the wire size to number 10 or number 8 to provide a safety margin and account for potential future increases in load. Using a larger wire size also reduces voltage drop, which is the decrease in voltage along the length of the wire due to its resistance. Excessive voltage drop can cause the pumps to operate inefficiently, overheat, and shorten their lifespan. By upgrading to number 10 or number 8 wire, the voltage drop is minimized, ensuring that the pumps receive adequate voltage for optimal performance. Furthermore, the use of number 14 wire inside the Intermatic timer box is also a significant concern. Number 14 wire has an even lower ampacity than number 12 wire, typically around 15 amps for typical installation types. Since the Intermatic box is internally wired with number 14 wire, it cannot safely carry the combined current of both pumps. This can cause the number 14 wire to overheat, potentially damaging the timer box and creating a fire hazard. The recommendation to upgrade the internal wiring of the Intermatic box to number 12 or number 10 wire is crucial to ensure that the wiring can safely handle the load. In addition to the issues with breaker capacity and wire size, the use of a freeze protection relay in the Intermatic box also raises concerns. A freeze protection relay is designed to automatically activate the pump when the temperature drops below a certain threshold, preventing the water in the pump and pipes from freezing and causing damage. While freeze protection is important, it should be implemented in a safe and code-compliant manner. The existing setup, where the total current for both pumps is routed through a temperature-controlled relay before reaching the timers, is not ideal. This configuration places the freeze protection relay in a position where it must handle the entire load of both pumps, which can overload the relay and cause it to fail. The recommendation to place the freeze protection relay on its own circuit with its own breaker addresses this issue by isolating the freeze protection function from the main pump circuits. This ensures that the freeze protection relay is not subjected to excessive current and that it can operate reliably without affecting the performance of the pumps. As for the double throw breaker, it's not explicitly clear from the context why it's inappropriate. However, double throw breakers are typically used in transfer switch applications where you want to switch a load between two different power sources, such as utility power and generator power. In this pool pump setup, it's unlikely that there's a need to switch between two different power sources. Therefore, the use of a double throw breaker is probably unnecessary and potentially confusing. It's better to use standard single pole or double pole breakers that are appropriately sized for the load. In conclusion, the wiring installation described is not safe and does not meet electrical code requirements. The concerns about breaker capacity, wire size, Intermatic box wiring, and freeze protection are all valid. It is essential to have a qualified electrician inspect and correct the wiring to ensure the safety of the pool and prevent potential electrical hazards. Remember, electrical work can be dangerous, and it's always best to consult with a professional to ensure that all work is done safely and in compliance with local codes. Ignoring these issues could lead to serious consequences, including electrical shock, fire, and property damage. Therefore, it's crucial to take the necessary steps to rectify the wiring and ensure the safety of everyone using the pool. Electrical safety codes are in place for a very specific reason, and it is important to follow the NEC guidelines. The NEC, or National Electrical Code, is a set of standards that governs the safe installation of electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, NFPA, and is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Its primary goal is to protect people and property from electrical hazards. Compliance with the NEC is essential for ensuring the safety of electrical installations. Most jurisdictions in the United States have adopted the NEC as law, making it a legal requirement to follow its provisions. Failure to comply with the NEC can result in fines, penalties, and even criminal charges. In addition to the legal requirements, following the NEC also makes good sense from a safety perspective. The NEC is based on decades of experience and research, and it incorporates the best practices for electrical safety. By following the NEC, you can significantly reduce the risk of electrical hazards and ensure the safety of your home or business. When it comes to pool pump wiring, the NEC has specific requirements that must be followed. These requirements cover topics such as grounding, bonding, and the use of ground fault circuit interrupters, GFCIs. Grounding is the process of connecting electrical equipment to the earth, providing a path for fault current to flow back to the source. This helps to trip the circuit breaker or fuse and energize the circuit in the event of a ground fault. Bonding is the process of connecting all metal parts of the pool and its associated equipment together, creating a low impedance path for fault current. This helps to equalize the voltage potential between different metal parts and reduce the risk of electrical shock. GFCIs are devices that monitor the current flowing in a circuit and compare it to the current returning. If there is a difference of more than a few milliamperes, the GFCI will trip and energize the circuit. This helps to protect people from electrical shock in wet or damp locations, such as around a pool. The NEC requires that all electrical equipment associated with a pool, including the pump, be properly grounded and bonded. It also requires that all receptacles and electrical equipment within a certain distance of the pool be protected by GFCIs. In addition to the NEC, there may be local codes and regulations that apply to pool pump wiring. It is important to check with your local building department or electrical inspector to ensure that you are in compliance with all applicable codes. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to perform the work. A qualified electrician will have the knowledge and experience to ensure that the wiring is done safely and in compliance with all applicable codes. When hiring an electrician, be sure to check their credentials and references. Ask them if they are licensed and insured, and ask them for examples of their previous work. It is also a good idea to get multiple bids from different electricians before making a decision. The cost of pool pump wiring can vary depending on the complexity of the job and the materials used. However, it is important to remember that safety should always be the top priority. Don't try to save money by cutting corners on electrical work. It is always better to spend a little more money to ensure that the job is done safely and correctly. Pool pump wiring is an important part of pool safety. By following the NEC and local codes, and by hiring a qualified electrician, you can ensure that your pool is safe for you and your family to enjoy. Remember, electricity and water do not mix. Always exercise caution when working with electrical equipment around a pool. If you have any doubts about the safety of your pool wiring, consult with a qualified electrician. The safety of your pool depends on it. Finally, always ensure that you get the proper permits for the work that is being done, so that the work is inspected by the local authority. This is the best way to ensure that the work has been done correctly.